Hello everyone, in this video I'm going to analyze a bakery sales dataset. So we will start by importing our libraries. So I'm using a Jupyter notebook. So I set NumPy, Pandas and matplotlib. After typing this, I'm going to run this cell. So in our next cell, I'm going to be loading the CSV file. First, you need to know where you have saved your CSV file. As for my case, my CSV file is saved in a folder on my desktop. While importing the CSV file, I'm going to use the pd.read CSV function. So inside this function, we are now going to pass in the file path of our dataset. So as you can see, mine, just click on this tab up here and copy the dataset, the file path, and paste it here. So at the end, as you can see, the file path is not containing the actual document. So you can just come back and copy the file name of our CSV and go back and use a forward slash and paste the name of our CSV file. And remember to end with .csv as the suffix. So before we continue, you can at the before the start of the opening quotation mark, you can include an R. As when I run this, it will print out it will print out a portion of my dataset. But whenever we move on ahead, we might want to recall your dataset. Doing so, we need to save this under a variable. So in my case, I'm going to call it df, such that whenever I need this dataset, I can just type in df and it calls out my dataset. You can now df. This one is when you use the df.head. This is a function that is used to call out your dataset. So it's used to print. It's a function that can be used to print out your dataset, but in this case, it only calls out or prints the first 5 rows of your dataset. You can put any number inside the bracket. Let's say when you say run the first 10, you can see it produces the first 10 rows of your dataset. Now to view our data, you type it df info, and when you run this cell, you get a general overview of your data. So in this case, you can see we are having five columns, as you can see, which is similar to what we saw earlier. You have the transaction number column, items, date, time, day part, and day type. Also, here we have the transaction number, items, day time, day part, and the day type column. All our columns have values, they are not empty columns. And you can see the transaction number column, the data type in the transaction number column is integers, while the other columns, they say they contain strings. So this is just a simple way of having a general overview of your data. df df just represents data frame, while the info, the info in brackets, this is just a method available in Pandas that is specifically used to obtain information about the data frame. So after having the general overview of our data, we can now move on to performing some descriptive statistics about our data frame. So when I say descriptive statistics, this is just a simple way of providing a summary of descriptive statistics for the numerical columns in our dataset, and this may include the count, the mean, standard deviation, minimum value, quartile ranges, and the maximum value. This is also part of just having a quick overview of the data. To do this, we use the describe method. So just again use df.describe. So describe is just a method again in Pandas that can be used to obtain such information. So when I use the df.info and run this cell, as you can see, the only data in this case is the transaction number, because it's the only column in our data set that contains a numeric value. Again, this is just another brief overview of our data. As you can see, we have the mean, the count, standard deviation, minimum value, the quartile ranges, and the maximum value of our data. In the data cleaning, there are various ways of cleaning our data, but in this case, since this is just a simple data set, I'm just going to use the checking for duplicates and dropping the duplicates. So while checking for duplicates, there are several ways you can use to check for duplicates. One of the methods is using the conditional statements, as the if-else statement. So if I'm going to use the if-else statement, this one just prints a statement that says if my dataset contains the duplicates. But using the duplicated method, this method returns a Boolean value, either true or false. So by true meaning that the dataset has duplicates, while false indicates that the dataset has no duplicates. So I'll start with the first one, the if-else statement. So when I run this code, you can see it prints out a statement saying duplicates are present. So that means that from our data sets, there are duplicates. So as you can see in my first line, let me just explain my first line of code. In this first line, I've said that if my data frame contains duplicates, sum of the duplicates will be greater than 1. This means that if my data set contains duplicates, that means there are many sets of the duplicates. And when you sum those sets of duplicates, of course, the sum will be greater than 1. So you print out that duplicates are present, but else if there are no duplicates, just print no duplicates exist. Now, the other method that I described, which is using the duplicated method in Pandas, so I'll start with data frame. So df just describes my data frame. As I said, this one prints out is the Boolean value, which is true or false. So based on this method, we can see that row number 2 prints out true, which tells us that this row is a duplicate. So after checking for duplicates, we can now move on to dropping these duplicates. So in Pandas, the method that is used to drop duplicates is the drop duplicates method. Then inside the brackets, I'm going to use a parameter. This is a parameter that is set to modify the data frame itself without creating a new data frame. So this means that the original data frame, df, will be modified and the duplicate row will be dropped from it. And while dropping the duplicates, the first occurrence of each duplicated row is retained, while the subsequent duplicates are dropped. As you can see, that the second row that contains Scandinavian was dropped from our dataset. We've dropped the duplicates. Now our data frame is clean enough to proceed to the next step. After cleaning our dataset, removing the duplicates, we can now move on to conduct an item frequency analysis. Also, another thing that we are expected to do is to do a transaction count. Another thing that we do is the day parts analysis. So this is from the day part analysis, we analyze the distribution of transactions across different parts of the day. That's the morning, evening, afternoon, or night. Also, another thing that we will determine from our dataset is the weekday versus weekend analysis. So this is just to check the traffic, the transactions that were made on weekdays and weekends, maybe to understand the variation in customer behavior and pattern sales within the weekdays and weekends. Also, the last thing that we are going to analyze, this one we will use the time series analysis, and we are going to determine the trends and maybe the seasonality. So we'll begin with the item frequency analysis. So for item frequency analysis, what we are expected to do is to determine the frequency of each item purchased to identify the most popular products in the bakery. So in our items column, you can see, let's say in this, we have the bread, Scandinavian, hot chocolate, jam, cookies, coffee, tea, pastries, smoothies. So we are going to first group these items into another column and check the frequency of the items that were being sold. First, since I'm going to extract data from my data set, the first thing to do, I'll create a variable. Let's say I'll create a variable and name it item count. So I need to extract that. So when I say df, I'm referencing my data frame, as you can see above. So items represents the column items. Now this statement value count is the value.count is going to count the unique values of each item that are present in my items list. Okay, so when I print that, as you can see, this is the result of of me extracting the items from the column. As you can see, I have the index, which is the index column contains the items, while the items column contains the frequency. So this is my data set that I've extracted from my original data frame. Now from here, maybe I can at least change the names of the columns to make it easier while using. So when changing the names, at first I'm going to call the name of the column that I'm going to change, that's the index. So index, then pass in the name that I'd like to change to. Let's say so. This is how we extract our new column, and from our new column we have saved our new column item count. So whenever I'm going to do anything, let's say manipulate data from this data set here, I'm going to call this variable. So let's say if I'm going to change the names of the column names. So when changing the column name, we use the rename method. As you can see, we have changed the names of our column from index to item list, now from items to frequency. So this just makes it easier to work with them, because you know specifically what you are targeting. So from here, we can now move on to plot a horizontal bar. So at start, what this does is that it takes the items list and set them into my new variable called items. Also, so I'm stating my x and y axis. So the bar with the H represents a horizontal bar. Then From here, I'll describe my horizontal bar. As you can see, this is my horizontal bar. We have a lot of items, that's why it's a huge horizontal bar. On the x-axis, I errored here a little bit. So this should be the y, the x-axis. Yeah. So when you run this again, as you can see, coffee is the most bought item, followed by bread, tea, cake, pastry, sandwich. So once we are done with this, we can now move on. So in this case again, just as like we did in our first case, in our item frequency analysis, we are just going to repeat the same. So again, for easy analysis, we can still change the names of these columns as we did earlier. The best visualization of this is a pie chart, or we can also use a bar graph. So let's first use a bar graph. So a new bar graph. The y-axis represents the total number of transactions, while the x-axis represents the day parts. Now that we are done, we can then move on to the time series analysis. For time series analysis, our interest is on calculating the number of transactions within a time period. We are going to calculate using two methods. So what I'm going to do with the first method of just using the date, I'm going to separate the date time column into date and time. From that separation, then we are going to determine the specific period. Then we filter our data, then count that the transaction in the filtered data set. So to begin with, I'm going to convert I'm going to convert the date time column to a date time data type. We are converting our date time column, this one, to a date time data type. The second step So from here, as you can see, we have the transaction number column, the items column, the date time column, the day part, and the date type. But what we have added to this is the date column and the time column. So the next step to this, we are going now to determine the specific period. So with this, we are going to name two variables: the start date variable and the end date variable. So for the start date variable, our value that we're going to use in the start date variable is the start date that we want to analyze from. The next step is to filter the data. So when calling the start date from the date time column, it should be greater than or equal to the start date and less than or equal to the end date. From here, we are going to calculate the count of transaction in the filtered data set. Alternatively, you can change the start date and the end date depending on what range you are looking. So for me, I started from the beginning when the transaction were recorded to the end to the end. So if maybe I want to check transaction that only happened in 2016, so I can just change the end year to, let's say, 2016. So 12th of month, then 31st. So when you do this and run this code, you see the only transaction that happened between 30th of October 2016 to 31st of December 2016 were only 4,806 transactions. So maybe we can then move on to using the date time. With the date time, we are going to specify the date and the time. So with this, we start by importing. We start by importing the date time. Start by importing the date time mode. Then again, you determine the specific period. So again, so you pass in the start date and the time. You then now specify your sequence of the year, month, day, hour, minutes, and you also do the same for end dates. I can just copy this one, then just change the values. The total number of the transaction is 15,131. So as you can see, we are getting different figures in terms of the number of transactions. So the difference why we are getting the two different results, yes, yet we are quoting the same period of time, is that the date only data typically represents a broader time period, such as a day, while date with time includes a more precise information, such as the hours, the minutes, and the seconds. So in this case, the difference between these two can be attributed to the specifics of the time, because when we look at the data distribution, is that the distribution of your data mostly varies depending on the time of the day. And then move on to calculate the transaction growth over time. So with this, we can use an area chart to effectively visualize the cumulative transactions count over time. So we are checking how have our transactions been growing over time. When I call our new data frame, as you can see, we have generated a new column count. So and this column, cumulative count column, is the one we are going to use when plotting the area chart to visualize this. So we move on to now plot our area chart. This is our cumulative count area under the curve, and as you can see, since 2016 to the last date, our transactions have been growing over time. I introduce an element here, color blue, so that you can see the edges more clearly. So as you can see, this is a way of representing such type of data, showing how transactions have been growing with time. So from here, we then move on to something monthly sales analysis. For the monthly sales, we are going to group our data into the respective months with respect to the year. So with that, we are going to see how much transaction we have been making every month, right? Let me just first call my data frame. So we are going to separate the transactions for every month. I get a new table having the year and month properly separated. So we have separated the months and the years into two columns, and we have summed the transactions that happened in every month. From here, we then move on to visualizing the results into a bar graphs. And then the bar graphs we separate between years so that we are able to see the total transactions that were happening within each year and with their respective months. So to start with, we are going to separate the monthly sales data from each year. the monthly sales for 2016, as you can see from the bar chart, you can see the analysis of monthly sales for 2016. They were rising until November, then December they got higher. Then at the start of the 2017, sales were good until they declined starting from April, May, June, and they seem to average out as from September. So basically, this is how you can plot these bar charts. So from here, you can then move on maybe to sales trend analysis. The sales trends analysis, this one is very important when determining the seasonality, because seasonality detection, basically it refers to the process where we identify and understand the presence of recurring patterns and cycles in our time series data. So it involves analyzing the data basically at different times to determine if there are predictable patterns that repeats at fixed intervals, such as daily, weekly, monthly, or year cycles. So when detecting the seasonality, it's very important because at most it allows us to understand the underlying patterns and the trends in the data, which are very important in decision making, also when forecasting and possibly planning. So for the sales trends analysis, this is the code snippet that I'll be using. So you might pause for a second and just type this code. So you show this and you run. This is our sales trend analysis. Basically, it's just an aggregated monthly sales of 2016 and 2017. As you can see, between the 10th month and the 15th month. So October, November, December. So we can see we were rising steadily. Then after around 14th month, for the 14th month, that was our peak, this one. Then we took a huge drop in the sales, as you can see, then until the end. So this is a very important way of maybe visualizing our sales trend analysis. So this is the end. So overall, this is how you can use Python, especially to do a data analysis. As you can see, we used in my example, we used it's not a complex data, but we just used the Pandas and matplotlib in our analysis. As I said, it's just a simple data set that maybe didn't require more things, because this is just an introductory example. But as we proceed more and more, we find that we'll require more, maybe NumPy in addition to the Pandas and matplotlib, and maybe seaborn when plotting, I think, more complex visualization. But basically, this is just a start, so we can maybe start from here, gain the basics of maybe using pie charts, or maybe using how we are going to plot pie charts, bar graphs, yeah? And maybe trend lines, as we did with the sales trend analysis, or maybe even if we are going to use the cumulative transaction count over time. Thank you for your time. Thank you for staying around until the end. I'm happy to teach, to learn from you, to hear from you in the comment section. So also take time to subscribe, comment, share, like. Thank you.